In 9.4, we're going to multiply square roots. So just as in the previous section, when we said square root of a times b equals square root of a times square root of b, now we're going to go backwards where we have square root of a times square root of b equals square root of a times b. So that's what, and so we're just going to go so that we have two square roots, multiply them together, and have one square root. So let's say that we have square root of 5 times square root of 2. What we can do here is just multiply the two numbers, and we keep them under the square root. 5 times 2 is 10. In this situation, they don't have to be the same because we're multiplying. We're not adding. Just like when we could say x times x squared, they aren't exactly alike, but we can multiply them to get x to the 3. Same thing here. We can multiply any numbers that are inside there. Now let's say that we have square root of 7 times square root of 7. When we do that, 7 times 7 is 49, so we have square root of 49. But the square root of 49 is a perfect square, and it is 7. So what do we notice here? If we have the same number that's a square root multiplied by itself, our final answer just becomes that number. And that's an important concept that we need to use, that we're going to use later on. So if we ever have square root of x times square root of x, the answer is just going to be x. You don't have to put square root of x squared, which equals x. That is what we have here. It is also, we could have even said square root of x, the whole thing squared like that. But just knowing this property is something that we're going to use later on. So whenever you have the same number under the square root sign and you're multiplying it, you don't need to put the square root of whatever they're multiplied here. You can just put whatever number is there. So some numbers that we can use, say we have square root of 6 times square root of 3. 6 times 3 is 18, so we have square root of 18, but we can't just leave this as our answer because we have to go as far as we can. And remember that 9, which is a perfect square, will go into 18, so this is square root of 9 times 2. We can take the square root of 9, which is 3, square root of 2. So always check to see if you can take a square root of something. So now let's look at square root of 10x times square root of 2x. Now I'm going to do this two ways. First I'm going to just multiply everything. So 10 times 2 is 20, and x times x is x squared. And remember, we can do 20. 4 will go into that 5 times, so 4 times 5 times x squared. Square root of 4 is 2, square root of x squared is x, and we're left with square root of 5. Now remember, we have the x times square root of x times square root of x, so we could have just brought that out to begin with. So we had x square root of 20, and then x times square root of 4 times 5, which is going to be 2x square root of 5. It doesn't really matter that much on this one because there were more parts to it, but if you notice these type of things, it's best to get in the habit of pulling them out right to begin with because it makes it so that you're less likely to make some mistakes. So let's say now that we have square root of 7, and then in parentheses, square root of 7 minus square root of 3. So we can't do anything with what's in the parentheses here because they aren't like. So now we can just use the distributive property, and we're going to say square root of 7 times square root of 7, and remember that's just going to be 7, and then we have a minus square root of 7 times square root of 3, which is going to be square root of 21. And that's as far as we can go here. Let's say that we have square root of 5x times square root of x minus 3 square root of 5. So we're going to distribute the square root of 5x. So on this one, I am going to, I'll do this one again the two ways. So I'm going to say square root of 5x squared minus 3 square root of 25x. So all I did was square root of 5x 5x times x is 5x squared. 5x times 5 is 25x. So I didn't do the little shortcut. I'll do that part next. Here I can take the square root of x squared, which is x, and I still have square root of 5, and then minus 3 times the square root of 5, 25 is 5, and I still have square root of x. So I have x square root of 5 minus 3 times 5 is 15 square root of x. Now if I had done this just seeing what the squares are, square root of 5x times x, square root of x, so the x can just be pulled out, and I'm left with square root of 5, and then minus 3 times, we have 5's under the square roots, so that can be pulled out, and we're left with square root of x, so x square root of 5 minus 15 square root of x. So it is a lot of times easier just to pull the numbers out or the letters out when you have them there. Now let's say that we have square root of x plus square root of 5 times square root of x minus square root of 3. So now we're just going to do FOIL. Square root of x times square root of x is just x. Square root of x times negative square root of 3 is minus square root of 3x. Square root of 5 times square root of x is plus square root of 5x. Square root of 5 times negative square root of 3 is minus square root of 15. And I don't have any like radicals or any like terms, so this would be the final answer here. Now let's say that we have square root of 3 plus 8 times square root of 3 minus 8. Okay, I'm going to do this as FOIL, but then I'm just going to use a shortcut. Notice here, it's just like a plus b times a minus b, which would be a squared minus b squared. So if I do a squared minus b squared, it's square root of 3 squared is 3, and then minus 8 squared is 64 equals negative 61. So that's doing the shortcut because we see that we have the same thing here, but one's plus, one's minus. But let's say that I'm not noticing the easy way to do something. So I'm going to do it with FOIL. Square root of 3 times square root of 3 is 3. Square root of 3 times negative 8 is minus 8 square root of 3. 8 times square root of 3 is plus 8 square root of 3. 8 times negative 8 is negative 64. If I combine like terms, 3 minus 64 is negative 61. Negative 8 square root of 3 plus 8 square root of 3 is 0. So the answer is negative 61, which I got here as well. Then let's say that we have square root of 5x plus 4, the whole thing squared. So here I'm going to do the shortcut where I square the first one, and I'm just going to get 5x. Then I'm going to say 2 times the first times the second. 2 times square root of 5 is 2 square root of 5 times 4 is plus 8 square root of 5x, and then square the last one plus 16. And that's all that we would have to do there because none of these are the same as each other. They're not like terms or like radicals.